So now that we've talked about the Java function functional interface, let's turn our attention to its big brother, the BiFunction functional interface. And we'll talk about how the BiFunction functional interface works. It's really just a slight variation on function functional interface. And again, we'll show how it can be used in the context of lambda expressions and method references. We'll show an example, which is the EX11 project in my FP folder in my modern Java GitHub repository. And this example will showcase the use of the Java collection frameworks, ConcurrentHashMap class, and the set interface. So you get a chance to see how both of those things get applied here. So what is a BiFunction? Well, a BiFunction is effectively a function on steroids in that it applies a computation on two parameters, not just one, and returns a result. The parameters that are provided here are defined as generic types. You can see we have T, U, and R. And the apply method takes a T and a U, which could be different types or the same type, and it returns R, which could also be a different type or the same type as the T and the U types. So that's essentially the generalization that we have provided for BiFunction versus function. Let's see how we can apply the BiFunction functional interface. So once again, we're going to come back to our running example of the three stooges, and we're going to use the stooge IQs with their names, and we're going to store that in a concurrent hash map. And then we're going to do a couple of interesting things here. So first thing we do is we create a map of the stooges and their purported IQs. Once again, this is just meant in jest. The stooges were actually quite clever comedians who made a lot of money playing idiots in a vaudeville act. So we're going to give Larry an IQ of 100, Curly an IQ of 90, and Mo an IQ of 110 because he was always the smartest of the stooges. And then we're going to show a couple of different ways you can manipulate this map. So the first thing we're going to do is we're going to use a good old-fashioned Java for each loop. And it's going to loop through every element in the entry set. And so you can see we're going to have this map of this map entry of each element that's in the set, and it's going to be the stringed integer mapping. And what we're going to do is we're going to take each value, which is the stooge IQ, subtract 30 IQ points, and then update the value in the entry, which will have the side effect of updating the value in the map. The alternative way of doing it, which demonstrates the use of the BiFunction functional interface, is to pass in a BiFunction lambda, which will look as follows and work as follows. You can see here we say replace all, and we're going to pass in K and V. And K and V are, of course, the key and the value that we're using here. And this is going to be using a BiFunction. And it's going to go ahead and take the value, subtract 30 from it, and then have the effect of updating the value in the map. So that's how you can use a BiFunction lambda, which is a little bit mysterious looking at first, I agree, but it works quite nicely and you got to get used to it if you're going to be using these methods in various parts of Java. Unlike the entry operations we see here, another benefit of using replaceAll, in addition to getting rid of the loop, is that replaceAll operates in a very highly optimized thread-safe manner. So if you call replaceAll in a multi-threaded program, you'll end up with sensible results, whereas if you use that loop in a multi-threaded program, you're going to end up with all kinds of chaos and insanity. Let's take a look at how the ConcurrentHashMap uses the BiFunction interface under the hood. So here's the replaceAll method, and you can see that it takes a BiFunction, and this BiFunction is oddly enough called function, and it's going to go ahead and apply it with two parameters. One is the key, and one is the old value. And then it creates a new value and updates that in the map. So here's the mapping that's done. The BiFunction parameter is bound to the lambda expression v minus 30. So you can see that we're basically taking the key and value portion, and then we're going to go ahead and subtract 30 from the value, and then that will go ahead and update the value in the map. That's just the way it works. And if you look carefully at the code, you can see that's what it's doing. Down here, you can see that it iterates through the map. It actually is doing a nested for loop. And it's going to go ahead and apply the BiFunction with old value minus 30. And so basically, it's as if it was replacing the apply with that particular result. So we're updating new value by taking the old value and subtracting 30 from it, because that's what we bound it to be here with the BiFunction parameter we passed in the lambda expression shown there. So that's the end of the walkthrough of the Java BiFunction functional interface, a very useful capability, by the way.